In the previous part, we talked about the atmosphere, rotation, surface features, and early telescopic observations of Venus. Now let us continue the story of how humanity explored Venus. Just think about it. Galileo's simple telescope, nothing more than a combination of a few lenses, was enough to completely transform humanity's understanding of the universe. From that moment on, humanity knew that it was not the center of the universe. The Earth, along with the other planets, all revolve around the sun. This discovery did not make humanity smaller. On the contrary, it made humanity greater, because we had the courage to question, the courage to explore, the courage to accept the truth. When the 20th century arrived, humanity was no longer satisfied with just gazing at Venus from afar here on Earth. They wanted to go and see for themselves. In 1962, the American Space Agency launched the Mariner 2 probe. This was the first probe in human history to successfully fly past Venus. At its closest approach, Mariner 2 came within 35,000 kilometers of Venus. Using a microwave radiometer, it detected that the surface temperature across all of Venus showed no significant differences. It was just as hot by day as by night. This confirmed that Venus was a planet wrapped in a thick atmosphere, suffering from an extremely severe greenhouse effect. The Soviet Union was also very active in the exploration of Venus. Between 1967 and 1969, they launched 3 probes: Venera 4, Venera 5, and Venera 6, all designed to probe the composition of the Venusian atmosphere. They also attempted to land on the surface of Venus, but sadly all 3 attempts failed. Before the probes could even reach the surface of Venus, they were crushed by the immense atmospheric pressure. Try to imagine it, a probe made of the most durable metal, meticulously engineered, slowly descending through the atmosphere of Venus. And then the pressure builds and builds, the metal shell begins to deform, begins to buckle. In the end, the entire probe is crushed into pieces. You can begin to feel just how extreme, just how merciless the environment of Venus really is. Then came 1970. The Soviet Union launched the Venera 7 probe. This time humanity finally succeeded. Venera 7 achieved the first soft landing on another planet in human history. It operated on the surface of Venus for just 23 short minutes and sent precious temperature data back to Earth. 23 minutes. In the long span of human history, it is nothing but an instant. But that single instant marked the moment when humanity's footprint formally extended to the surface of another planet. Then, in 1974, the American Space Agency launched Mariner 10. This probe was the first in human history to fly past more than one planet. First, it went to Venus. Using Venus gravity, it performed a gravitational slingshot maneuver, borrowing the planet's gravitational pull to alter its trajectory, and then headed onward to Mercury. Picture it. The probe is like a traveler in space. It does not need to burn its own fuel to change direction. Instead, it borrows the gravity of a planet to push itself along, saving an enormous amount of fuel. The forces of nature are truly both wondrous and elegant. In 1975, the Soviet Union launched Venera 9. This was the first probe in human history to successfully enter orbit around Venus. Its lander also captured the first photographs in human history of the surface of Venus. From those photographs you could see that the sky of Venus is yellowish, completely without the blue sky and white clouds of Earth. The surface rocks appeared in a rust-like color. All around was a landscape of flat, rocky terrain. The whole scene to us truly looked like something out of hell. Beneath a yellow sky stretched a field of rust-colored rock. No water, no plants, no trace of life whatsoever. Everything was still, desolate, scorching. Yet within that desolation you could also sense a peculiar kind of beauty, a pure beauty, raw and untouched by any living thing, primordial. By 1983, the Soviet Venera 14 probe, after successfully landing, even managed to capture the sounds of the surface of Venus. This was the first time humanity ever heard the sounds of another planet's surface, compared to the sounds of wind on Mars that we had heard before. The sounds on Venus' surface were deeper and fuller, because the density of Venus' atmosphere is 93 times that of Earth's. The way sound travels through the Venusian atmosphere is very different. You would hear a deep, low wind and perhaps the sound of distant thunder. The entire sonic environment would feel as though you were inside a vast enclosed chamber, deep, heavy, and oppressive. In 1989, the American Space Agency used the Space Shuttle Atlantis to launch a Venus probe called Magellan. The mission of Magellan was to map the entire surface of Venus. Because Venus is covered by such thick layers of cloud, ordinary optical cameras are incapable of photographing its surface. So Magellan used synthetic aperture radar technology, using radar waves to penetrate the cloud layers and scan the topography of the Venusian surface with crystal clarity. It worked for a full 5 years, producing high-resolution maps covering 98% of the surface of Venus. When its mission ended in 1994, Magellan was intentionally sent plunging into the Venusian atmosphere. Throughout its descent, it continued to gather atmospheric data without stopping. Roughly 10 hours later, it burned up completely, becoming a streak of light in the atmosphere of Venus. A 10-hour fall, and it worked the whole way down right until the very last moment. That probe was truly so dutiful, so moving. After completing its mission, it stayed forever on the planet it had explored, becoming a part of Venus itself. Since then, Europe's Venus Express, Japan's Akatsuki, and others have all taken their turn exploring this mysterious planet. The story of Akatsuki is especially interesting. In 2010, on its first attempt to enter Venus orbit, it failed. The main engine malfunctioned, and without the ability to decelerate, it missed Venus entirely. But the scientists did not give up. They used the smaller attitude control thrusters on Akatsuki to slow it down. After 5 years of patient waiting and precise calculations, it finally succeeded in entering Venus orbit in 2015. This story tells us that even when you face failure, as long as you have patience and wisdom, you can still succeed in the end. There are many more Venus exploration missions planned for the future. The one nearest to us in time is the American Space Agency's DAVINCI mission, expected to launch toward Venus around 2031. It will drop a probe into the atmosphere of Venus, and during its descent, analyze the atmospheric composition, investigating the origin and evolution of Venus. There is also the VERITA's mission, which will use advanced radar to map the surface of Venus once again, at even higher resolution than Magellan. Perhaps by then our understanding of Venus will have grown just a little bit more, and we will learn even more secrets about this mysterious planet. When we speak of Venus, we absolutely must mention the phenomenon known as the transit of Venus. The transit of Venus is perhaps one of the rarest astronomical phenomena in the entire solar system. When Earth, Venus, and the Sun lie in exactly a straight line, due to the extreme contrast in brightness between Venus and the Sun, we would see Venus appear like a tiny black dot slowly gliding across the brilliant surface of the Sun. This is the transit of Venus. There are, of course, transits of Mercury as well. Mercury transits are somewhat more common, occurring about a dozen times per century, but the transit of Venus, that is truly rare. Venus transits occur in pairs. 2 consecutive Venus transits form one pair. Within a pair, the time interval is 8 years, but the time interval between one pair and the next exceeds 100 years. For example, the pair of Venus transits in the 19th century occurred in 1874 and 1882. The last century had no Venus transits at all. Nobody in the entire 20th century ever saw a transit of Venus. The two Venus transits of this century occurred on June 8, 2004 and June 6, 2012. For the vast majority of people to see two Venus transits in one lifetime is already a matter of great fortune. Because if you missed these two, you would have to wait until the next pair, which will not arrive until 2117 and 2125. Why is the transit of Venus so rare? Because the orbital plane of Venus around the Sun and the orbital plane of Earth around the Sun are not on the same plane. There is a tilt angle of about 3.4 degrees between them, so most of the time, when Venus moves into the space between the Sun and the Earth, it passes either above or below the Sun and does not pass exactly across the face of the Sun. For a transit of Venus to occur, Venus must cross precisely at the intersection point of its orbit and Earth's orbit. This condition is extremely stringent. It is like standing at a very, very great distance and trying to thread a very, very tiny bead through a very, very tiny needle's eye, off by even the slightest fraction, and it will not work. If you have been fortunate enough in this lifetime to see a transit of Venus, you will surely remember that image forever. A tiny black dot, slowly, slowly moving across the golden backdrop of the Sun. The entire process is so quiet, so graceful, so sacred. The light of the Sun remains dazzling and blinding, but upon its surface there drifts a single small black dot in silence. As you watch it, you will feel as though time has stopped. You are witnessing an astronomical phenomenon measured in centuries. You are participating in a significant moment of the cosmos. That feeling is something that no photograph or video can ever replace. If you missed both of these chances, do not feel regret. The universe always gives us some things, and it always takes some things back. The stars we get to see in this lifetime, the astronomical phenomena we get to witness, these are things that countless predecessors could only dream of. We can use telescopes to observe the phases of Venus. We can look at photographs of Venus' surface transmitted back by probes. We can know the temperature and atmospheric composition of Venus. These are all things that people in Galileo's era could never have imagined. So rather than dwelling on what you have missed, be grateful for everything that we have right now. And now let us talk about the possibility of life. This is a topic that is so deeply fascinating. When people today discuss whether there could be life on the surface of Venus, the usual first reaction is to say, it is impossible, because the environment of Venus is simply far too hostile, from the sulfuric acid clouds in the atmosphere, to the extreme heat and pressure on the surface, to the lack of a magnetic field. Any form of life within our understanding could not possibly survive in such conditions. The most extreme heat-loving microbes on Earth can at most survive in environments around 120 degrees, but the surface of Venus is 472 degrees. That exceeds the known limits for any form of life. However, according to current research findings, even though the surface of Venus is so hostile, there is a region about 50 kilometers above the surface where the environment is, astonishingly, quite similar to the surface of Earth. At this altitude, the atmospheric pressure is about 1 times that of Earth's surface. The temperature ranges between about 20 and 30 degrees Celsius. The level of solar radiation is also similar to that at Earth's surface. Apart from the different atmospheric composition, the physical environment at this altitude is practically a replica of conditions on Earth's surface, and so some scientists have put forward a very bold vision. Since this layer of Venus atmosphere is so similar to Earth's surface, why not build a floating city right here? Humans could live inside enormous airships and floating platforms, forever hovering above the cloud tops of Venus. Because the density of Venus' atmosphere is so high, a giant balloon filled with Earth air, that is, a mixture of nitrogen and oxygen, would float naturally in the Venusian atmosphere, just as a helium balloon floats in Earth's atmosphere. So you would not need any kind of engine or propulsion. Simply by the buoyancy of the air itself, you could keep an entire city afloat at the habitable altitude of Venice atmosphere. This concept was proposed independently by Soviet engineers and American Space Agency scientists. They named this plan the High Altitude Venus Operational Concept, or HAVOC. Try to imagine this scene. Floating above a sea of golden clouds, there hovers a city suspended from many enormous balloons. Below the city stretches an endless layer of sulfuric acid cloud, with hurricane-force winds howling far beneath. Above the city is the deep, starry sky. Inside the city, there are living quarters for humans, greenhouses for growing plants, and various scientific laboratories. Humans live and work here. Looking out the window, they see a vast golden sea of clouds and a sun that rises from the west. Because the rotation of Venus is so very slow, the sun would hang in the sky for a very, very long time, and you could take your time to savor every long sunrise and every long sunset. How dreamlike, how poetic that image is. Of course, this concept is very bold. It is even more difficult than the idea of migrating to Mars. If humans were to live there for a long time, the number of problems that would need to be solved is incalculable. First, all the materials used would have to be capable of resisting the corrosiveness of the sulfuric acid clouds. Sulfuric acid corrodes most metals and plastics. Finding a material that is both lightweight and corrosion-resistant enough to build the airships is already a major challenge in itself. Second, humans need food, water, and oxygen. None of these things exist on Venus. All resources would have to be shipped from Earth, or some method would need to be devised to source them locally from the Venusian atmosphere. For instance, using solar power to split carbon dioxide and produce oxygen, or collecting the trace amounts of water vapor in the atmosphere to produce drinking water. Third, the airships and floating platforms must guarantee sufficient lift so that they can stay permanently aloft and never fall. Fourth, given that the wind speeds in Venice atmosphere are so high, you would also need to figure out how to keep the city floating stably without being tossed around by the powerful winds. So at present, whether technologically or economically, humanity cannot yet achieve this. But it is precisely this kind of bold dream that pushes humanity ever forward. A few hundred years ago, flying into the sky was an impossible dream. But now we have airplanes, rockets, space stations. Perhaps a few hundred years from now, when future humans look back upon our era, they will see the idea of floating cities on Venus as something remarkably prescient. In September 2020, an international team of astronomers published a paper in the journal Nature Astronomy that sent shockwaves through the academic world. They reported that for the first time, phosphine had been detected in the cloud layers above Venus. Phosphine here on Earth is intimately connected to life. For example, inside the digestive tracts of penguins there are microbes that can produce phosphine. In oxygen-poor environments like swamps, there are also microbes that can produce phosphine. Of course, factories can also produce phosphine artificially, but on Venus, there are no factories, and there are certainly no penguins. So where might this phosphine have come from? Could it be that there are microorganisms living in the atmosphere of Venus that are completely different from anything on Earth? Microorganisms that, over billions of years of evolution, have adapted to the extreme environment of the Venusian cloud layers. Perhaps they have evolved an extremely tough protective shell that shields them from the corrosion of sulfuric acid. Perhaps they use carbon dioxide and sunlight to carry out some kind of chemical process that is entirely unknown to us, sustaining their own lives. Perhaps they have been floating in the clouds of Venus, surviving from generation to generation, never once detected by humanity. Of course, all of this is still just speculation. The team that published the paper was also very careful to emphasize that they were not claiming to have discovered life on Venus. The detection of phosphine only means that this finding is consistent with the hypothesis that anaerobic organisms exist in the atmosphere of Venus. There may well be other, as yet unknown, chemical processes capable of producing phosphine. Further research and exploration are needed before any confirmation can be made. But regardless, this discovery is deeply exciting. It reminds us that the universe is far more wondrous and full of possibility than we ever imagined. A planet that looks like hell on the outside, high up in its cloud layers, it might conceal forms of life we have never seen before. Just as in every seemingly hopeless situation, there may be hidden a tiny thread of hope. Perhaps one day a human probe will truly be able to gather evidence of life from the atmosphere of Venus. At that moment, the question that has troubled humanity for thousands of years, are we alone in the universe, will have a brand new answer. Even if that life is nothing more than the simplest microorganisms, to us it would be an epoch-making discovery, because it would prove that life is not unique to Earth. Life can emerge in any corner of the universe, so long as the right conditions are present. Now slowly relax. Gently set aside all the knowledge, the data, the stories about Venus. All you need to remember is a feeling. Imagine yourself floating 50 kilometers up in the atmosphere of Venus. The temperature here is just right. The pressure is just right. Everything is so gentle. All around you is a soft, yellowish glow. The sunlight, filtering through the sulfuric acid cloud layers above, turns into gentle golden rays that softly touch your skin. You feel yourself becoming very, very light, as if you have no weight at all. You are slowly drifting in this golden sky. Looking down, you see layer upon layer of cloud sea moving in slow, flowing currents, just like the ocean on Earth, except made entirely of clouds. Looking up, you see the deep expanse of space. Stars twinkle and shimmer. In the far, far distance, the Milky Way stretches across the horizon. The sun rises slowly from the western horizon, radiating its gentle light. It will hang in the sky for a very, very long time. It will not be in a hurry to set, because on Venus one day is equal to 1 year. Time is something to be felt, slowly and deeply. You do not need to think about anything. You do not need to worry about anything. All your troubles, all your pressures, all your anxieties, they have all been left behind on Earth. Right now you are in the sky above Venus, floating quietly, all alone. Nobody here will rush you. Nobody here will push you. There is nothing at all that you need to do. You only need to exist. You only need to breathe. You only need to feel this stillness. Your breathing grows slower and slower, more and more steady. With every inhale, you breathe in the stillness and gentleness of this golden sky. With every exhale, you breathe out the tiredness and the tension in your body. Your shoulders are fully relaxed. Your arms are fully relaxed. Your legs are fully relaxed. Your whole body has sunk into the mattress, wrapped in warmth and safety. Venus is just such a contradictory planet. From a distance, it looks so similar to Earth. Yet up close, it is the complete opposite. It has been called Earth's sister planet, but it is more like a mirror held up to Earth by the universe, reflecting a world that is starkly and utterly different. It has the most hostile surface environment in the solar system, yet its high cloud layers are surprisingly similar to the surface of Earth. It has no magnetic field for protection, yet it has still managed to hold on to its thick atmosphere. It spins so incredibly slowly, so slowly that a single day is longer than a year. It is the planet closest to Earth, and yet how limited our understanding of it still remains. It is like how every person may contain a completely different world inside. Some things look so simple, so similar on the surface, but when you truly draw near to see, to understand, you discover the complexity and the depth hidden within. Venus is a reminder given to us by the universe, a reminder not to be fooled by outward appearances, but to look more carefully with the heart, to feel more deeply, to understand more profoundly, and now gently let go of all your imaginings about Venus. The golden cloud layers, the towering volcanoes, the slow rotation, the distant probes, the possible life. Let them all turn into gentle images, softly drifting into your dreams. Just hold on to that feeling of floating, that feeling of weightlessness, of no pressure, of being completely at ease. You are drifting slowly like a tiny speck of dust, floating quietly high up in the clouds of Venus. All around you is a warm, golden glow. In the distance stretches the boundless, infinite universe. There is nothing you need to worry about, nothing you need to fear. Everything is so quiet, so peaceful, so gentle. Breathe slowly. Sleep well. Sweet dreams.